Okay, so I'm just going to record what I'm doing. One class, someone who's going to be out asked me to, and I can't remember which one, so I figure if I record all the classes, then I'll be covered. So you guys want me to make up a new problem, right?
Well, I could pull off the car. I could probably find it on the website.
No, you guys should make up a new one. You don't think I'm capable of making up a new one? So insulting. Accepted, you know, I know all these things accepted. Okay.
I found out that the
What is hold on. Alright, so let's see. Alright, I need to invent a problem. Abby, can we have you driving? Okay. So we're going to put Abby in a car here. Driving. Okay. Who else? Who else wants to drive? You drive? Okay, we'll make Olivia drive. And Olivia, do we make her heading? You wanted them heading together, right?
Yeah.
Okay, Olivia is coming the other way. That's okay. I give you a cooler car. Look, we'll even give you a rear spoiler. The engine's internal on most cars. Here, exhaust pipe. It has an internal engine. And let's say Olivia is moving this way at 12 meters per second. And we'll have Abby. Is Abby okay? Do you want Abigail?
No, I'm fine.
Abby's fine, okay. Moving this way she's slow at 5 meters per second. How far apart should we have them start? $273 meters apart. And we want to know how long till they meet and at what point do they meet. Okay? Okay? All right. So, we would start off by, we'd write a Y about them moving in opposite directions, and they're going to meet when they're at the same place at the same time, right? And that we can actually do this two different ways. I think I'm going to do it twice, all right? Just to show you two different thoughts. We're going to do it first in the reference frame of the Earth. So if I'm standing outside of this and I'm seeing it, what am I going to see? Okay? And then I think we'll come back and we'll do it in the reference frame of Abby. Okay? So in you sure? So the nice thing about doing it in the reference frame of the Earth is we're very familiar with that, and we already have all of our values that we need. The bad thing is that both things are moving. Okay? So that's the bad part. And the good part is that we know a lot of things. So if we switch to Abby's frame of reference, we have to do a little bit with relative velocities to figure out like how fast is Olivia moving. But then we only have one thing moving, Olivia, and our life is easier that way also. All right. We're going to take this location as 0 meters, which means that Olivia starts at this location of 273 meters. could I have picked that reversed? Yeah. I could have put the 0 right in the middle too, right? Which way do you guys, ladies and guys, want to call positive?
Right.
To the right. Okay. So I'm just going to remind myself by putting an arrow with a little positive, just so I don't forget.
Mr. Crocker, how would
Yep.
it be, like, would there be any way that positive could be left if
Sure.
0 was on the left?
Sure.
Because I should have been 0.
Because I can put 0 anywhere I wanted. Probably if I picked to the left, it would make more sense, as Olivia said, to put 0 down there. But that 0 location is arbitrary. I probably would, if I picked positive to the left, I probably would change that to negative 273.
Oh, okay. Oh, God.
So my physics equation that I'm going to use for my equation sheet is this one. All right, that's even though I didn't bring up my equation sheet, that's directly copied from it. So it's saying vector. No, that means original. We should probably put OL. Olivia.
Wait, will we be finding like the reference frame of Olivia too? I'm using them.
I wasn't going to do it in her reference frame, but we could.
But oh, so
I'm just going to show you 2 ways to solve the same problem.
oh, okay.
Just because a lot of times, if you had a situation like this, I would do it from Abby's frame of reference so I had less things moving. But the Earth's frame of reference is so much more familiar with you guys, I think you'll be more comfortable doing it in the Earth's frame of reference. Does that make sense? Okay. So this is our equation. I know they're going to meet at this, so what this equation says is where I end up is where I started. That's that D naught. And this is really how far I traveled because I was moving during that time. Remember, we can only add things if they're the same things. Apples to apples, oranges to oranges. Can you add apples to oranges? No. No. Even in a fruit salad it doesn't work. But, no. It's weird. So, for Abby, I'm just going to use D is where Abby's going to end up. She started at 0 meters. She's traveling at positive 5 meters per second for some amount of time. Olivia ends up at D also, because that's where they meet. Remember, that's in our Y, to meet same place at the same time. She started at 273 meters. She's moving at negative 12 meters per second, and she moves for the same amount of time. Now, I've got 2 equations which have the same 2 variables. So I know I can solve this mathematically, right? If I have 2 equations and 2 of the same 2 unknown variables, I can solve it. If I have 3 equations and I have 3 same unknown variables, I know I can solve it. There's a couple, I could do algebra here to solve it, right? Set them equal to each other and solve for t. I could solve one for t and put it into the other one, and then I'd be solving for d. This is also a point I could pull up even on the test, pull up our website.
Why is it negative 12? You can pull up your website and
Sorry. And use the solvers on the link.